Fine. Now, if you see in last session, what we did was we just understood what actually Hadoop is in basics, and also we collected the binaries and made our system ready to configure Hadoop. Okay. Now, today's objective is to ensure that we are successfully configuring our Hadoop, and apart from that, we are understanding internals of HDFS. Right. So today's session will be important because it is going to play important role in order to explain you the core concept of HDFS, and probably once you understand this, you will be capable of understanding the internal architecture of Hadoop as well. Right. So now what we'll do, we'll start up. Fine. Now, initially, what we will do, we'll understand all different steps of configuring Hadoop, then we will understand HDFS, and probably after that, we will start configuring our Hadoop for a clustered environment. Okay, since we don't have a number of machines at your end in order to configure it in a cluster, we will go with the second approach, which is pseudo distributed mode, which is similar to clustered environment, but it will be there on a single machine. Okay. Now, to start up with Hadoop, just a brief what we did in last session. In last session, we understood that Hadoop contains two very important components, which was actually borrowed from Google white papers, which they released in order to reflect their capabilities of indexing, searching, and working with big data. And those two papers were translated, and a product came up in Apache, and that particular product was called as Apache Hadoop. Now, file system of Hadoop was exclusively made on basis of GPS, that is you say GFS, that is Google file system, and it was named as HDFS, that is Hadoop distributed file system, and MapReduce was borrowed in order to provide a programming model to Hadoop. So using combination of HDFS and Hadoop, we get a reliable, fault tolerant system of handling big data in order to complete our task when it comes to streaming of huge amount of data and providing better throughput as compared to pre-existing systems. Okay. Now, if you see how actually we are going to configure Hadoop, we know that there are three different modes. One is standalone. In standalone case, all different components of Hadoop will run in same JVM. So you can use it for your development and testing of MapReduce and various other parts of Hadoop. Then second is pseudo distributed mode, where actually we implement a cluster, and each component will run in a different JVM coordinating with each other. We will be able to set up our Hadoop ready for streaming huge amount of or huge volume of data. Third one is clustered environment, which is the actual production environment, and in that particular production environment, we are going to ensure that we are able to interact with the Hadoop system in order to again meet the required throughput and necessity of the systems. Right. Now, how actually we are going to configure? In order to configure, what you have to ensure initially is you have to ensure that you have the required setup done at your end. Let's take a production environment. Now you will have there something called as racks. Now each rack will have a number of commodity hardware. Now each commodity hardware can have a number of hard disks, right? Now what you are going to do is you are going to set up your Hadoop on this particular architecture, where you are getting commodity hardware along with the required hard disk distributed across various racks. Okay. After ensuring that your architecture is ready, you are going to configure your Hadoop, where you will definitely adopt master slave architecture, which was adopted by Hadoop, and you will specify what all commodity hardware are going to play a role of master and what all hardwares are going to play a role of slaves, right? Now, just in order to briefly tell you, your master will take responsibility of coordinating all activities which are going on in slaves. Actual read and write operations, which will be requested by client will go on, you say slaves, and slaves will contain what? Actual data nodes, right? So you can now say that my name node is something which is master, and that name node will keep track of entire task which is going on data nodes which are slaves, right? So when client makes a request, he will place his request to name node. Name node will provide him a list of data nodes where actually he can go and write or he can read from, right? And this list which is created smartly after reading lots of network configurations which are there in order to ensure that in case if one hardware fails, how best other hardware can take over that particular failed hardware, right? So basic objective of Hadoop is to provide you a reliable, fault-tolerant system in order to store data and provide you access to that data, right? Now, before we start, let's go and understand what all are the important components which are there in Hadoop setup, right? And that is what you are going to work with also, right? Now, if you see, when we talk about Hadoop, in Hadoop, the entire process will be called as a job, right? And this job request will be placed to name node, which will contain something called as job tracker. Now, this job tracker will take responsibility of dividing the job into n number of tasks, and these tasks will be taken care by your task tracker, and each task tracker will coordinate task which is going on in slaves, right? So if you see how actually Hadoop works, Hadoop client initiates process which is termed as job. Job tracker takes responsibility of dividing that particular job into a number of tasks, and it schedules the task to run on various nodes, right? Basic responsibility of job tracker is to keep track of who all are going to participate in the activity, monitor all the processes, orchestrate data flow, and also handle failure with the right algorithm which is written for job tracker. Okay. Now this task tracker keeps on reporting to the job tracker. Okay, and this reporting is done through something called as heartbeat, right? So in case if one of the node is down, there will be no heartbeat emitted by that particular node to the master node, which we call as name node, right? In case, assume that 10 minutes time, if there is no heartbeat reflected or emitted by a data node, your name node will consider it dead, and then it will start doing housekeeping tasks, right? Is this clear? What all important components are there, right? Fine. So these are some of the important components which need to be started up when actually your Hadoop process starts, right? Now what we will do is, we'll just go through the steps first, what all steps are required in order to configure Hadoop in fully distributed mode, right? So we all are ready. In previous session, we have practically done configuration, or you say installation of Hadoop, and when we wrote Hadoop version, it was displaying the version which is configured, right? So what I'll do, I'll just show you what we have done in last session, output of that, so that we can proceed from there and we can start configuring. I'll go to my Linux box. I have taken a new Linux box, and here I'll move to bin directory, and I'll write here Hadoop version, right? And this was the message which we all were getting, and we ensure that we all are getting this message in order to ensure that today we are in the loop, right? Now see, what I'll do is, I'll show you that how I will come to know that my Hadoop system is configured or it is not configured. So I'm just going and starting up the process, start all .sh. And if you see, it is doing what? It is trying to start name node, and whatever is output, it is logging onto log files, right? So you see, it tried starting name node, it tried starting data node, it tried starting secondary name node, it tried starting job tracker, and then it tried starting task tracker, right? Now since we have only one data node by default, for that particular data node, it tried starting the task tracker, right? Now, rest of the components we have discussed, like what actually is role of name node, what is role of data node. Now, data node actually provides the actual block storage capability. We have also just discussed what is job tracker and task tracker. Now, one component is there which we have not discussed, that is secondary name node. Now, please understand that the secondary name node's responsibility is to do housekeeping. Like whatever your name node is doing, it will get recorded, or you say image of name node will get shared with secondary name node as well. So that in case if your name node is shut down or it is down because of some reason, data is not lost, or metadata which was stored in name node is not lost, right? Now please understand that secondary name node will not take over as name node, right? Its responsibility is just to do housekeeping task. Okay, its responsibility is to ensure that whatever metadata and whatever uh, nodes information, whatever startup time was recorded in the name node, all that information or metadata is present in secondary name node as well, right? So now if someone is asking you, hello, Padma, are you able to hear me? Okay. Now, if someone is asking you, tell what are the important architectural components of Hadoop, very simple. You will say name node, second, data nodes, third, job tracker, fourth, task tracker, fifth, secondary name node, right? So what we did, we tried starting our Hadoop processes, and let's go and see whether it has started or not. Okay, in order to see what all Java processes are running, we'll just go and write JPS, and you'll find that only one process is running, right? But actually, we tried starting 4 different processes. It means something has gone wrong, right? So let's go and see how we will come to know what has gone wrong, and that will come to know through Kranti. Job tracker is someone who intercepts the client request, breaks down it into n number of tasks, and submits it to task manager, right? Fine. Now, if you see how we'll come to know what went wrong. So what I'll do, I'll go to files, and in files, I'll go to my Hadoop installation directory. In this, we will have logs, and if you see, recent logs will get recorded here. This was the log which was created. I'll just go and open it. Let me open it. I'm opening it, and if you see here, you will get the info. Now, if you see, all exceptions are there. Now, what is the basic reason of exception? It is saying does not contain a valid host or port, right? To be very simple, it simply means that you have not configured your file system, that is HDFS. Your current start all.sh is unable to locate your data node, name node, and rest of the component because we have not configured it yet, right? So what we have to do, we have to go and configure it. And what we are going to discuss now is to ensure that we are configuring our Hadoop so that our log tells us that you have successfully started Hadoop, and when we do JPS, we get all different processes running. Okay, is it clear? So how actually you will come to know that what problem actually was there in starting up Hadoop? Okay, that you will come to know through log files. So if you see, you have log files, and this is for data node, this is for then data node, and this is for job tracker, right? You can go and see job tracker also. If I go and see what was the reason, and here you will come to know does not contain a valid host or port. It means we have not configured. Same is the case with name node. If I go to the name node, you will get similar kind of error where it will tell I'm not able to understand on what host or port I have to start the name node. Okay, so it means file system is not aware about the environment where actually you want to start up your Hadoop processes. Okay, is that clear? Come on, if I go here and write Hadoop version, you see here it tells, right? This is what is the version. So in this case, it is able to find out the version, right? Is that clear, Numan? In your case, if it is not working, probably it's because some environmental variables are not set. If you remember, last step that we did was what? Export, and we created Hadoop, install, and here we specified what? Folder. But I went to my bin directory and there I am writing /Hadoop version. Okay, so we'll test it out post session, right? As of now, we'll just go through the steps because in last session, Numan, it was working, right? Hadoop version. Yes, Numan. Yeah, it was working. So if it is not working, it's only because some environmental variables, or you might have shut down your uh, virtual machine, and once you shut down, whatever you do at command prompt, basically it gets lost when you start it up again, right? So I'm not going to, I have not told you actually to maintain all these commands in bash, so that once you start up your virtual machine, all these exports are added. But anyhow, we'll test it once we are done with the configuration steps. Okay, is that clear? Fine. Now let's move and see what all steps are there that we have to follow. Right. Now, in order to configure your Hadoop now, once you have all binaries present, what you have to do is you have to understand the process first, how actually Hadoop starts up and where actually it goes and tracks the components, right? So when we start name node, or when you write start all.sh, it tries to start your name node, right? If name node configuration file is configured properly, it will go and look for slaves under slaves file, and it will use SSH to start data node in the remote server at the startup. Okay, so it goes to slaves. In slaves, whatever IP address you have specified, that also I have told you in last session, important configuration files. If you go here again to Hadoop, you will have two very important files. One is slaves and second one is masters, right? So whatever node you, on whatever box or on whatever machine you want to start up slaves, that is data node, you have to go and specify here, right? As of now, everything is there in the same box, so we'll keep it localhost. Same is the case with masters. Whatever node you want to treat as name node or master node, you have to go and specify its IP address, right? So since we are doing all on local machine, let's keep it as localhost itself. Okay, so these two are important configuration files which we use in order to specify our data nodes and our name nodes, right? So what will happen when name node process will start? It will go to slaves. In slaves, it will go and see the IP addresses. After looking at IP addresses, we can say it will be doing a ping using SSH, and it will start the data node. Okay, it's clear. Now, when you go and start job tracker, it finds slaves through the same directory which we have seen, and then it fires start task tracker. Okay, now in our configuration which we are going to do, we cannot go and exclusively start job tracker. Job tracker actually gets started whenever a map reduce program is executed, right? Fine. So as of now, we understood the process. What happens when you start, when you specify start all.sh, it goes to the configuration files. From configuration files, it picks up the information, starts the name node, goes to slave, start data node, then job tracker is started. Once that job tracker is started, it again uses SSH in order to start the coordinating task trackers. Okay, it's clear, and most of the things will be automated, so you need not worry. Till here it's clear, right? What all are the important components which need to start up and how actually startup process is executed, right? So we'll move now. Fine. So first thing that you have to do here is you have to go and configure SSH itself, right? If you see, you have to do installation of SSH server, and SSH server that we are going to use is OpenSSH. Okay, it's very simple how to install. You have to just go and use this sudo apt-get install OpenSSH server. I'll be sharing this material with you, and all this installation or configuration you will be doing post session once we understand the steps. Okay, and then you will be doing SSH localhost. Now, after doing installation of this, once you do SSH localhost, it will ask you for password. Okay, fine. Once it will ask you for the password, you specify the password, you will log in. But what we want to configure our SSH so that no password is required, and automatically like SSH goes and logs in. Okay, for which what you have to do, you have to configure and generate key first. In order to generate key, this is what is the command: SSH keygen. RSA is the family, -p is the password, and if you see, we are specifying here an empty password, and then -f indicates where actually your key should be stored. Okay, it's clear. Now these steps are Linux steps. Fine, you are preparing your Linux box or Mac box in order to provide you a no password logging to SSH shell. Okay, which will be used by your Hadoop to start job tracker, task tracker, and also data nodes. Is that clear? These two commands are clear. I need prompt. Krishna, Srujan, because it will help me to understand that I'm audible. Okay, now once you have generated the keys, you have to copy the key to a particular location, right? So if you see what is the location, this is what is the key which is created, id_rsa.pub. This is what is the key, and this key we are copying where? To authorized keys. Okay, now once you have done this setup, which I have already done, you will find that you are able to log in SSH cell without specifying any password. For example, I'll go here and I will write here SSH. If you see, it is providing me the options. I will do SSH localhost because I want to connect to localhost in order to send the signal of starting up the data node and job tracker and task tracker. I'll just go and press enter. If you see, it tells me welcome to Ubuntu, and now I am connected to SSH shell. Okay. See, SSH is a process, or it's a software that provides you capability of talking to the remote systems. Okay, it helps you to specify or secure your connectivity or you talk to a number of other boxes. Is that clear? Yes, for security. Okay, Srijan is asking why it needs SSH server. See, when we talk about communication, remote communication, right, it has to create a packet, and when it creates a packet, it has to send that packet, which will be hello, you say machine, right? You know, it's a request to connect to other system. Now, it goes along with the key and a password. You can say it goes along with the user context, so that other system can decide whether he has to have handshake or he has to reject the connection. Okay, so in order to ensure that whatever boxes are there where actually you have done your setup of Hadoop, as of now you don't want any password to be used. in order to create the connection. Okay, so what we will do, we'll create or we'll configure our SSH server to create a packet where it adds up the credential and provides automatic authentication without taking credential details from the user who actually wants to connect. Okay, is that clear? So even if you don't use SSH, you are going to communicate to the remote systems, right? So in order to have a layer of security, you will go and use this SSH. Okay, fine. So what we did, one of the requirement of Hadoop is to ensure that your SSH server is there, because it enables secure communication with rest of the nodes you say, boxes you say, machines you say. For our configuration, we are going to generate a key without any password so that security part can be externalized from your setup. Okay, and we will be doing securing your Hadoop nodes and all later, at a later stage, after we are comfortable with working with Hadoop file system, map reduce, and various other components. Okay, Sujan, is that clear? Right. Now what we will do, after copying the key, you will go and test, which we have just now done, right? We have tested and it got us connected to the local host without asking for any security. Okay, so these are the steps that you will follow in order to ensure that your SSH is configured. Okay, till here it's clear. Fine. Now next task is to go ahead and prepare your system. Okay, so that you can dedicate a part of your hard disk, you say, or a part of your disk, you say, where you are going to have your HDFS file system up. Okay, now please understand that HDFS file system is an abstract file system, right, which can sit on top of FAT, which can sit on top of NTFS, which can sit on top of various other file systems which are there, right? There are various file systems which are adopted by various servers. For example, Yahoo in its architecture uses a different file system, Google uses a different file system, right? So in order to provide abstraction to those various file systems, Hadoop came up with concept of its own file system, which will abstract the existing file system from the Hadoop layer. Okay, and that is what is called as HDFS, right? Now, what part of your disk or which directory you are going to use as HDFS file system, that is what you have to configure. Right, so be careful, because that is what we are going to see now. See, what you need to do is, in all machines, you have to go and create a directory for storing HDFS data. Okay, you can give whatever name you want, and creating directory is as simple as creating directory in Linux. Okay, so you have here mkdir Hadoop data dir, right, and inside that you have to create two other directories, subdirectories you say. One is name. Name itself tells you, right, that it is for name node, which will contain what? Image or metadata information. And then you have data. This data will be for data node. Okay, so you can say these two subdirectories will be created, which we are going to specify to our Hadoop that please use this particular subdirectory for this purpose and use name for this purpose. Okay, so as of now we have created two subdirectories under our main directory. Okay, so let's go and create it here. I'll just go and see what is my present working directory. I'll just go, and you can create anywhere, wherever you want. Okay, it's not necessary that you have to create where I'm creating. You can create wherever you want. mkdir, I'll go here, Hadoop data dir, right? I'll move in Hadoop data dir, and now I'll create two other directories, right? Let me call it as data, and here let me call it as name. So we have the directories set up. Okay. Next step is to provide appropriate permissions to this directory or to these directories. Okay. Fine. So if we go and see what is the next step is to provide the permissions. You see chmod is what we are using and we are providing 755, right? If you don't know Linux, I'll provide information on how to provide permissions and what is meaning of 755, right? It's combination of 3 different privileges for which we specify using numbers, so that you will see in the documentation itself. But as of now, we are going to provide the permission. Okay. So we'll just write chmod 755 and specify name of the directory. Same is the case here. You can go and specify the same permission to name. I'll come out here and I'll specify permissions to Hadoop underscore data underscore dir. So right. So I'll just go here and specify. We are missing some argument. Right. So you have to just go and specify the right permissions to the directory. Right. So I have provided permission to entire Hadoop itself. What is the data? I'll just go and specify the right directory here. Right. So all permissions are granted now. Fine. So this is what is your second step after you have your binaries. First step is SSH. Second step is manage or create directories where you are going to keep your configuration files. Okay. Now this you will be doing in all systems wherever you want to store HDFS data. Okay. Is that clear? Fine. Next step. Next step is what you have to do is we have already done in the name node change directory to unzipped Hadoop, then place IP addresses of all slave nodes in the Hadoop underscore home conf slave file, right? So you have to go to that particular box which you want to treat as name node. Inside that you will go to that slaves folder which we have seen and we will specify name of all data node systems or IP address of all data node systems with a new line character. Okay, so this is what ensures that your name node is now aware about all data nodes, right? So for each data node, it will go and coordinate and start a task tracker. Fine. So this is how actually you will configure or you will make your name node aware about slaves. Okay, it's clear. Yes, Sujin, Rajni. Right. Numan is, it's clear, right? Fine. So some prompts are needed. Now what we need to do? We need to go into conf directory again, and here we are going to specify the required configuration in order to ensure that our name node, job tracker, task tracker, secondary name node and data node get started up, right? We have already analyzed the log files before, what messages it was giving. As of now, we will discuss about only few of the configuration, but as we move deeper into Hadoop, we will go and we will talk about few more, right? So if you see, before adding the configuration, replace the master node string with the IP address of the master node, and Hadoop underscore data underscore dr with the directory that you have created, right? So this configuration we are going to specify on the name node. We'll go to name node and we will just go and edit three important files. One is core site.xml, second is mapred site.xml, and third one is HDFS site.xml. Okay, so these are the files. Let me show you where you will get all these files. You will get it in conf itself. You have HDFS site, you have mapred site, and you have core site.xml. So these three are primary files which need to be used in order to provide the startup information for your Hadoop pseudo distributed mode or even for cluster. Okay, fine. Now important here is what entries we need to make. Okay, now in order to tell you what entries you have to make, be careful because these are important entries which are required, and there are very few. I have tried minimizing number of entries which are required in configuration files. So if you see in core site.xml, you have to just specify fsdefault.name, right? Now this is the URL of the master node or the name node along with the port. Okay, now this master node in our case will be localhost. Is that clear? So let me just go and copy. Just see the process, right? We are copying it, or we can go and enter also there. As of now, let me avoid copying and pasting, right? So you have to just go and specify fs default name. This master node in our case will be localhost. Why I have specified master node? I have specified master node that assuming that you are doing it in a clustered environment. So assume that you want to treat box whose IP address is 129.x.x.y as your master name node. You have to specify IP address of that particular box. Okay, so this is what is one simple entry that you have to make in your core site.xml. Is that clear? Okay, fine. Numan, it's clear, right? You'll remember configuration is the root element, property contains name and value. So whatever properties we will discuss, we will specify it in the right file with right name, because these are the properties which are read by your startup file and it configures your Hadoop on the values that you have specified. Okay, now if you see, important here is we are using a protocol called as HDFS. Okay, it's clear. Instead of using TCP, instead of using file, we are using HDFS protocol, right? So this is what is first file where you have to go and we have to make entry, right? Fine. Next file, which is very important. It is HDFS site.xml, right? Now here what we are doing is we are specifying two important properties. One is DFS name.dir and DFS data.dir. Okay. Now DFS name.dir points to the directory which contains your name node related metadata information. Here is it stores the required data, and then you have dfs.data.dir. So whatever streaming of data you are doing and distributing across different data nodes, that will be stored in this particular directory called as data itself. Okay, which we have already created. Is this clear? Now in the same file you can specify your you say checkpoint directory also, which we will see a bit later. Okay, in the same file you can specify replication also, that how many copies of data need to be made available on data nodes, right? By default it is 3 copies. It means if you are writing a data to your HDFS file system, it will automatically create 3 replicas and it will store that replica in different data nodes. Why it stores it in different data nodes? Because for example, if one data node is down, your name node will go and will collect the same piece of data from other nodes, right? So you will not lose the data at any point of time. You can configure how many replicas you want to maintain, and that you do by specifying, you say DFS dot replication. Okay, so instead of this, you say you can have one more property added to it. Let me go and specify that so that things become simple for you. Instead of data.dir, we'll change it to DFS dot replication. Okay, very important in case of failovers. Okay, fine. And here you will specify a numeric value. Say I'm saying 3, okay, or I'm saying 4, or I'm saying 5, right? How many replicas will be created? That is what you control from here. Okay, fine. So these are, you said, 3 important entries which will be specified in HDFS site.xml. Is that clear? Padma, is that clear? Right. Next file is for your map reduce. Okay, where we are going to specify job tracker, right? Task trackers, right? How many task trackers, right? How many map task tracker, how many reduced tasks must be executed? What is the Java or amount of heap that you want to use, right? All these configurations are done in MapRed. As of now, we are using few of them. If you see MapRed job tracker, you are specifying master node. Here we will have IP address of our box where we want to use our, or which we want to use as name node, right? And we have specified here IP, right? If you see, this IP is different as compared to IP which we have specified in core site. Here it's 9000 and in MapRed it is 9001. If you will specify 9000, there will be a conflict. Okay. Then when your tasks are executed, it uses some temporary locations, right? So you can go and you can specify that what locations can be will be used when your map reduce tasks are running. So we have specified here Hadoop data dir/local. Okay, and then how many map tasks? Maximum map tasks 8. Similarly, you can specify maximum reduce task also. For example, I'll just go here and copy just to add, and if you see here, instead of using map, I have to just change it to reduce. So this configures what is the maximum capability of running a particular reduce task. Okay. Now, what is map reduce task? That we will see later. We know that whenever data is required by a client, he goes and he will make request in name node. Name node will tell him, see, you can go and get your data from these data nodes, right? And when it gets data, it has to do some kind of mapping and some kind of shuffling of data in order to get the desired result. Okay, fine. So we will go through that also, but as of now, what all are the important configuration units or elements which need to be there in MapRed site.xml, right? So these are some of them which you can use. Apart from this, you have many others which we will discuss depending on our requirement once we move forward in the course. Okay, it's clear. After doing all this, next task is pretty simple, right? Next task is, which we have shown you, format your name node, right? And formatting name node, why? So that it can host an HDFS file system at the specified location. Okay, so in order to format, you will be using Hadoop name node -format. Okay, so if you want to see help, you can just go here and go to your command prompt, move to the directory. Why I am moving? Because I have not set the bin path and all, right? Specify here the process, and if you see here, you have help, right? So balancer and all that you can start. We are, in order to format, you will be using name node. Okay, is that clear? So This is what you will be using, name node, right? Now this provides you information about name node, right? So you can go and you can specify or format. If you see here, it uses minus format, right? You can upgrade, you can roll back, you can finalize, you can recover, you can force, shutting down and all, right? As of now, it is not configured, so it is showing us what? Shutting down name node at this particular IP address, right? It's clear. So this is what is next task after you have configured all your file system. Go and format it. When you go for formatting, it goes, gets the directories which we have created already in Hadoop data dir with name called data and a name. It uses those two directories, formats it, and adds the required information so that your name node and data node can treat it as an HDFS file system, which abstracts your actual file system. Is that clear? Fine. Once this process is done, then you can go and start. Now when you start, after doing all this, you say configuration, and if everything is fine, you will find that name node has started. Task job tracker has started. Task tracker has started, right? All those elements will get started up. Is that clear? So processes in brief are clear. Fine. Now, along with Hadoop, if you see, Hadoop contains a very important folder here. If I go to the folders again, it contains a very important folder, and that folder is web apps. Okay, it means by default Apache Hadoop provides you certain web applications also to do monitoring. Okay, monitoring of what? Monitoring of data node, monitoring of HDFS, monitoring of job tracker, secondary node, task, and it contains all files. Like you see, it contains webinf, and it contains actually web applications. Okay, so internally when you start your Hadoop processes, it also starts an HTTP server. Okay, why it starts an HTTP server? So that it can help you in going and browsing your file system through a web application, and all that are hosted at that particular HTTP port. So if you see name node, you have at 50070, job tracker you have at 50030. Okay, it's clear. So you can say that Apache Hadoop comes along with a web server also, and it provides us web applications in order to go do monitoring and browse through the file system, HDFS file system and all. Instead of doing command line, you can go and you can browse your file systems from those particular web applications as well. You have to just go launch the browser, type this IP address should be IP address of your master node, right? Job tracker again, IP address should be the IP address of master node. In our case it will be what? Localhost, right? Yeah, it is going to be same because internally it is configured. Okay, if you want to configure, you can do that as well, but for that you need to know bit of you say web applications. Okay, if I go here, you'll find index, you'll have webinf, and all configurations are there in webinf. See here, it's all configured. What all are the servlets, right? So this is web application which is written by Apache. If you go with Cloudera, if you go with various other distributions like MapR and all, you will find better UIs in order to administrate. Why actually we do this training first on Hadoop and then we show you Cloudera and MapR, so that you can understand the core. Okay. Is that clear? Fine. So we'll be working with both, like Cloudera also I will show you, I will work with MapR also, and I'll try to work with Hornetworks also. In other words, I'm going to provide you two different commercial Hadoop implementations. Okay, so in market, some companies might be using Cloudera, some companies might be using MapR. IBM uses its own, right? Now Microsoft is also coming up with its own. So we have various flavors of Hadoop today, which is there in market. So once you are aware about Apache Hadoop, almost all flavors, 90% of Apache Hadoop, they are using, it's entirely similar. Yes, they have provided some extra tools in order to make your task easier, right? But I'm sure if you are able to understand Hadoop Apache, you will be you can start working with rest of the implementation quite easily, right? I need to just help you in migrating and explaining you architecture of those commercial products, which I'll be doing. Okay, is that clear? Fine, right. So we are clear with all configuration steps now. These are the steps that actually we follow in order to configure Hadoop, right? After formatting, go and start. If you have start all, you will have stop all. If you want to start name node, you can also go and use rest of the commands like DFS start and all, which you will find in bin folder of your Hadoop binaries. So if you just go to Hadoop folder, you'll get bin. In this bin, you will find all startup files. Okay, right? As of now, we are using what? Start all. You can go and you can start DFS. You can start map thread, right? If you want to start all the required processes, you can just go and start it using start all.sh. Okay, fine. So this is how actually you will be configuring your Hadoop. We will do it post session, in the sense after we are clear with rest of the concept which I wanted to discuss with you. We will go and again revisit the steps in order to ensure that today your Hadoop is configured and you are able to start working with it, start working with HDFS file system, right? At least from next session onwards. Fine. Now, a few things are there which we need to mandatorily discuss. We cannot avoid it, that how actually internally Hadoop works. Okay, so we'll not take a break as of now. We have to discuss how actually Hadoop works. Now, if you see, first thing that you need to understand here is that Hadoop is not like traditional application and hardware architectures, right? Even programming model called as MapReduce is entirely different as compared to the actual enterprise programming model which exists, right? In case of enterprise, what happens? You send the request, server processes it and send you back the response. Okay, but in case of Hadoop, you will find that when you send the request, few tasks are there which are automated and they automatically execute in order to provide you the benefit of whatever core idea Hadoop has in order to execute your task, right? So if you see, Hadoop actually is not interactive. Okay, most of the time it will do your processing in batches, right? So if you see, Hadoop application look like batch jobs used to calculate bills or transform data from database into a data warehousing, right? As of now, you have to just think that Hadoop does processing and it's not interactive processing, it is batch processing, right? Now, just like other processes, Hadoop takes a chunk of data, it does something to it and stick it somewhere else for another application to consume, right? And Hadoop does this on a massive scale. So scale, you say velocity, volume and variety. These three are primary keywords that actually helps you to understand objective of Hadoop, right? Now, for example, Hadoop is interested in data. It takes the data, but if you see, Hadoop is not interested in mutable data, right? Whenever you will change a data, a new piece of data will get created and it will be kept in the data node, right? It's not going to change the state of the data which already exists. Fine. So if you go to Google also, sometimes you will find pages or data in a result of search probably which does not exist as of now, right? Fine. So as of now, Hadoop does processing in form of batches. It takes data, chunk of data, and then distributes it to its commodity hardware, right? So that it can take advantage of all disks which are there, maximize the processing speed, and provide those benefits to the consumer. Okay. Now, part of this scale is achieved involving distributed computing, that is lots of commodity hardware which will be there. If you see, it can be tens, hundreds, or even thousands of commodity soft servers. These server nodes are grouped into racks. Okay, this is what is important, these terminologies. And racks are grouped into cluster, and all of them are connected by high speed network, at least 100 gigs. Okay, that is what should be the capability of network, right? Then only you will get the benefit. So if someone is asking you, now tell me what is the architecture of Hadoop, you can say cluster. Cluster contains racks. Racks contains a number of commodity hardware. Now each commodity hardware may contain a disk or may contain a number of disks, right? So this entire architecture is actually used by your Hadoop in order to distribute the data, replicate the data, and whenever there is need, do some automated, or you say automated housekeeping task in order to ensure that the request made by client is processed in best possible way. Okay, it's clear. So now new terminologies are clear. What is rack, what is cluster, and what is content of rack. Okay, all this is configured. I will be doing it once we are moving to doing an actual clustered setup, right? So there I'll try to create at least 2 racks with some commodity hardware, and probably that commodity hardware will have at least 50 gigs or 100 gigs of dedicated space. Okay, fine. So this is what is first thing that you need to understand. Batch processing. Hadoop takes chunk of data and stores it in data node, right? Okay. See, within each box is called a node. Okay, it's clear. In that node, you can have a number of disks. So when you configure your data node, at that point of time, you go and specify what is the directory where actually your HDFS will be present, and that is done on all machines. So on all machines, you will have the directories. In case if one machine is down, other will take care of providing the data or facilitating you in read and write. Okay, fine. Now, how does Hadoop manage it? Right? It requires reliability. It requires data should not be lost. Right? It requires clients should not get affected if one of the node is down, and it also commits you a better programming model when it comes to searching of data or writing of data, a better algorithm, a better programming model, and most of the things automated, right? And that is what is done by these 2 important components of Hadoop. Okay, so if you see, Hadoop contains 2 important components. One is HDFS. Objective of HDFS is to split the data, put it on different nodes, replace it, replicate it, and manage it, right? So HDFS provides you capability of fault tolerance, right? If one data node is down, you need not worry, because the data is copies of data is scattered throughout n number of other servers, okay, or nodes, right? Now, very important here. HDFS organizes your information into consistent set of file blocks, right, and storage block for each node, right? So in other words, your data node actually is divided into a number of blocks. So assume that I want to store a file. Now, if I want to store a file, that file will be, you say that file will be splitted into n number of equal sized blocks, right? Fine. So for Hadoop file system, block is the primary storage unit. Now that block may consume storage block, which is your you say abstracted file systems block, which is of 512 KB, right? So one of the reasons why Hadoop is faster is because it is capable of loading 64 MB or even 128, it depends what size you are specifying of data. It's clear? So if I am storing a file, what happens? It breaks it down into n number of blocks. And what is the minimum size of each block? It is 64 KB or 64 MB, right? And internally it uses a small file system, actual file system blocks of 512 KB. Okay, it's clear. Now, where actually this block is stored? It is on data nodes. So if someone is asking you, okay, what is difference between file block and storage block? It's simple. See, I told you that HDFS is an abstraction of file system, right? Your file system provides storage blocks and your HDFS provides file blocks, right? So when a client wants to store a file, your HDFS will split it into a number of blocks, and that particular block will be internally linked to the actual storage of the actual file system on which you have posted your HDFS. It's clear? Fine. Now please understand one thing. Name node is not at all interested in storing data for you. He just coordinates. If you want to store data, you will just talk to name node. Name node will tell you that what is the best place for storing your data, right? HDFS splits your file into a number of blocks and writes that to the data node. Which data node? That is what is told to you by name node. Okay, it's clear. This is the reason why we say that in case if name node is down, your entire Hadoop goes for a toss. It becomes single point of failure, right? So in case of recent Hadoop versions, we have concept of having two name nodes, one in active, other in passive. So if one name node goes down, other name node takes over that existing name node. Is that clear? Fine. So this is what is one of the important component of Hadoop. Now comes how actually your HDFS works. Okay. Now please see the diagram, because probably this part is most complicated. I have tried trying something with diagram so that you understand it better. Okay. Now you see name node is the master node, right? Now here you have two files, data1.txt and data2.txt, right? Now data1.txt was, you said DFS does what? HDFS, it breaks it down into three blocks, 1, 2, 3, and data2 it breaks it down into two blocks, 4 and 5, right? So when user wants to store this data, or when user is asking for this data, your name node will tell where actually it will get it, right? So it will tell about the data. Let's take the write case first, writing of the data. Name node tells that these are the data nodes which are there. Client wants to write something, your HDFS breaks it down into blocks and replicate it to various data nodes. So if you see here, first block here, it is stored here in this particular data node, it is stored here as well, right? So you have how many copies of one? You have 3 copies of one, right? Same is the case here with 2. 2 gets stored here in these 3, because the replication is what we have set to 3. And I told you that you will have HDFS site.xml where you will have dfs.replication to set the replication factor. If you forgot, I can take you there back again. Okay, basic idea. Yeah, Padma, are you able to hear me now? Hello, Krishna. Okay, okay. Now, are you able to hear all of you? Am I audible? Okay, fine. So I was talking as Rajni asked me, is replication a required property? See, Rajni, basic objective of Hadoop is to provide you a fault tolerant system, right? So whenever client is asking for data, and in case if that particular node where your data is stored goes down, from where he will get the data. And objective of you say google.com is what? To provide you the best possible, fastest possible and accurate search results, right? So if some of the search elements are lost, which are important for client, it is something which Yahoo or Google will not like, right? This is the reason why we keep replicated data. Okay, is that clear, Rajni? If you don't want to maintain, fine, you can go and specify replication factor as 1. If you will not specify replication in the configuration file, by default it will create 3 copies. Least value is 1. Okay, fine. So I'll go back there because we have seen where actually we configure it. Now if you see for 4 and 5 also 3 copies, right? We have 3 copies of 4 and 5 also, right? So this is how actually HDFS works. Clients makes a request to write or read. Your name node returns a list of data nodes where actually the data can be written or can be read from, right? And then it goes and puts the block. Yeah. See, Padma, what we spoke here was that how actually HDFS works, right? So when a client makes a request, your request goes to name node. That request can be assumed writing data to a file, right? HDFS breaks down the file which you want to write into a number of blocks, right? Where each block will be of 64 MB default, and you can configure it to have 128 MB also, right? So here, first file it broke down into 3 blocks, and second file into 2 blocks. Assume that we are naming those blocks as 1, 2, 3, and 4, 5, right? So name node provides the list of the data nodes where actually this data should be written, right? And your HDFS ensures that it creates 3 replicas of the same data, and it places those replicas on different node, you say data nodes. Why it does it? So that in case if one data node goes off, if this fails, right? Again, 1 is present on 2 others, 2 is present on 2 others, 5 is present on 2 others, 4 is present on 2 others. So client will not face the problem. He'll get the file. Padma, is that clear now? Okay, so this is how actually HDFS works, right? So one of the important component of Hadoop is HDFS. It's a file system provided to you by Hadoop, which works on idea of GFS, Google File System. What it does, it abstracts the actual file system and provides you capability of storing larger chunk of data in form of blocks. Okay, it provides you inbuilt capability of fault tolerance or failover by ensuring that it maintains replica of the same data which you are writing on scattered data nodes. Okay, is that clear? Responsibility of name node is to return the right set of data nodes which should be used for that particular read or write operation. Okay, fine. Let's move forward. Why 3 copies? I feel that it's clear with you, right? What if one data node goes down, right? Then comes heartbeat, very important factor. See, one of the responsibilities of the data node is to keep on sending heartbeat to name node, right? If they are not sending the heartbeat to name node, your name node assumes it to be dead, right? and once it is dead, your name node has to maintain the right set of replica, right? If you have specified R equal to 3 and assume that one data node is down, so some replicas will be there on that particular data node also. Now name node has to maintain 3 replicas. So what it will do? It will respawn or recreate those blocks and it will write it in other data nodes which are present. This is what is meaning of heartbeat and respanning. Is it clear? Numan, Padma? It is not too expensive when we see at the larger picture that they compensate the memory. How do they compensate the memory and the expense? Kranti, when you go and adopt any architecture, you do lots of studies, right? And when you do lots of study, your objective is to ensure that ROI, that is return on investment, is satisfactory, right? So you will adopt Hadoop only when you are getting better ROI when you are using it. Hadoop tells you that, see, I need commodity hardware, I need n number of disks. Fine. If you are providing me all this, your search as compared to traditional or actual enterprise application may be faster as in Hadoop, because we are going to use parallel processing across different disks. We also commit you that we are going to take care of failovers, right? So if you want this kind of system, if you want your data should not be invisible or it should not be lost and rate of access should be faster, you have to make compromise at cost end and you have to go and use the hardware. Yes, Hadoop never asks you that you go and buy a service. Hadoop says you can use your existing commodity hardware. Is that clear now? Fine. So if you see, I feel that these 3 questions are answered. What is role of heartbeat? Send by data nodes to master. Okay. When respanning will occur? If one data node is down, master has to maintain the right number of replicas. Okay. In order to do that, it respans the blocks and stores it in live data nodes. Okay. Manoj, is it clear? Okay, Srijan. So I feel slowly you are understanding the way it works. Yeah, Rajni. The entire housekeeping will be taken care of name node. Okay. Okay, fine. Let's move further. Now we'll take up a actual architecture which is there at Yahoo. If you see at Yahoo, you have core switches. These are network switches, right? Then 100 racks, right? You have rack 1, rack 2, rack 3, 100 racks, and probably you have 40 slave per rack. Okay, means 40 commodity hardware in each rack, right? If you see 1 gigabit in rack memory will be there and 10 gigabit between racks, right? So if you see access speed will be within a rack 1 gigabit, because we know that once we have access to a rack, access will be faster. But when we have to switch to another rack, it is a costly affair. So here we need to keep high speed network, right? For that, if you see, we have 10 gigabit of runtime speed and total capability is 11 petabytes. It's clear. So this is what is the configuration which has been done at Google. Srijan, if name node is down, you are lost. This is the reason why you need to have a passive name node, so that once active name node is down, passive name node takes over. Otherwise, if you're not having this architecture, you have to go and find the reason and you have to start up your name node. So single point of failure in Hadoop is name node, for which now you have concept of having passive nodes, name nodes. Okay, so this is how actually Yahoo has it set up. Similarly, Facebook and all will be there, right? Fine. Now, this diagram actually helps us to understand a better approach of what happens actually when your name node is down, when your data node is down. Now, if you see, name node basically maintains metadata, okay, of files, right? It will not store the data, but definitely it will store that what was the file, what was the block, and it is stored in what data nodes. So, for example, here if you see file.txt, block A, block B, 2 blocks, and they are stored where? In data node 1, 7 and 8. So, if you see data node 1, 7 and 8 stores A, right? Similarly, B, data node 8, 12, 14. You have 8, 12, 14, right? And these nodes are numbered and they are there in different racks, right? Similarly, your name node is also aware about the rack and content of the rack. Rack will contain your data nodes. So if you see here, rack 1 contains 1 to 5, rack 2 6 to 10, rack 3 11 to 15. Is that clear? And we say that name node is rack aware. It means I can go and configure racks also. We'll do that once we move to clustered environment, right? Now, which rack contains what data node? Name node is aware about that. Now, if you see, replication happens smartly. It means when your name node provides you a list of data nodes, probably for replicating your data, it ensures that it is providing you the best possible data nodes, which are nearest to you, where you can say it will be better or it will be the best case of storing the data, right? So internally it contains algorithm which returns you a set of data nodes on different racks, right? So all that smartness is inbuilt in your Hadoop cluster, right? Now if you see, what if all replicas on the data node on same rack? Now take a typical case. Assume that your A block is stored in the same rack, right? And rack goes down. What will happen? Block will be lost. And if block of a particular file is lost, you lost that file itself. Is that clear? This is the reason why when replication happens, when replicas are created and when they are sent to data nodes, your name node takes responsibility or takes best care that it always is distributed across data nodes on various racks. Okay? Is that clear? Fine, Parma. So this is why rack awareness is important. Now let's take a case here, typical case of HDFS write. Okay. Now assume that you are writing files using copy to HDFS cluster. See, there are various ways actually in which you can go and write files. Okay, in HDFS. For example, you can use HDFS shell commands, you can use Java code, you can use Python scripts, right? Now, if you see what happens, client here makes request to name node. He says that, see, I want to write file.txt block A, right? And this client is what? This client is HDFS cell which is provided to you, or basically you can say Hadoop API, right? Client will be using Hadoop API, right? And that Hadoop API will take responsibility of breaking down or splitting up your file into n number of blocks and then coordinating with the name node, right? So your Hadoop API, using Hadoop API, your client says that, see, I have a file and I broke down that file into 3 blocks. You will not be doing. Who will be doing it? Hadoop interface, right? And I have broken it down into 3. Now please provide me where I should write this block A. Name node responds you. Let's see, you can write it on 179, right? And if you see, rack 1 contains 1, rack 5 contains 7 and 9, and Hadoop is responding you back with 179, right? So now 3 replicas will be created, which will be the default, and once name node replies back to client from then onwards will have direct access to data node, right? He will write directly to data node. He will not send again this data to name node, and then name node will do read and write for you. Please understand, name node will not do read and write for you. Okay, who will do it? Client. Okay, through API on the name node, on the data node, right? So once he receives the list, and if you see, this list is a you say collection, right, which is created by name node, keeping in mind best possible list of data nodes. Okay, so you got the list, you will send a request to data node 1. Data node 1 will say I am ready, and your chunk will be written to the data node 1, right? Is that clear? Now if you see, other data nodes where you want to maintain this replica are there present on different rack. So, yes, Rajni, it will be single, or you can say for that once you go through API, right, it will be clear to you, because as of now I cannot go at length and discuss with you the streaming logic, but yes, you will be writing logic using simple APIs, and internally it will be responsibility of that API or stream that you have selected to make the call. Okay. This is the reason why we create a job and then we submit the job. So that job contains your request along with the information that you want to write, right? So if you see here, when it has to move to a different rack, it uses the switch. Okay. So again, it uses the switch. Data node 1, rack 1 uses the switch and writes it in data node 7, right? And again it writes it in data node 9. So if you see, only one request, right, of write, and then rest is happening in your HDFS file system. So he need not make 3 calls to write or 3 write calls to 3 different data nodes for the same block. Is this clear? Okay. Okay, fine. So Prem, is this clear to you also? Kranti? Right. So now if you see, this is how actually HDFS writes will happen, right? Now there is a deviation also, we'll see, and that is what is called as pipeline write. Okay, so we'll just go and see what actually is pipeline write. See here, this is what is pipeline write. Now here if you see, client writes data after he gets the list of name node, right? And once he writes data to A, and then he uses the switch, writes it to B, again to data node 7 and to data node 9, and then he will tell it to name node that I have received the block. Okay, and he will send only one single success to the client. Instead of sending 3 different success, it will send one success. So now if you see, what is the entire flow? Clients makes request, name node returns the list of nodes of data node. Client writes it to data node 1, uses the switch to write to data node 7, not client. Data node 1 will pass it on to, or replication information will be passed on to data node 7, and data node 7 will pass it on to data node 9. And then all 3 of them will notify your name node. Once this notification is done, it will go and send the success flag to the client. Is it clear? Now, see, all this is going to happen automatically once you have done the setup. So why we call it as pipeline write is clear. You can see the diagram, and I think that you might have understood. Naren, is it clear? Yeah, Manoj, Narayan, I feel that it should be clear now. Okay, thank you. So this is how actually you will go and do the write. Now, if you see algorithm for read is also not very different. Okay, what happens? Client says that I want to read results.txt. Please give me the blocks. Okay, is it clear? This is what is the request. Because now client, if he wants to read a file, he will talk to name node and he will get the blocks. Right? So here name node responds back. See, this file has been split into two different blocks, block A and B. Block A is present on 1, 4, 5. Block B is on 9, 1, 2. Right? And if you see, this list is created smartly. So your client will first try to use what? Block A. He will try to go for 1. If 1 is down, 4. If 4 is also down, 5. Right? Similarly, for block B also, an ordered list will be returned. Right? And then from there onwards, client will have access to read the blocks from different data nodes. Is this clear? How read and write operations are managed by data node or data node and name node. So now if someone will ask you that what all components are involved, how actually read and write operations are performed in Hadoop, I feel that you can tell them the use case. Okay, that client makes a request to name node in case of read. Name node prepares smartly an ordered list of all blocks and their data node where they are present, keeping in mind network closest data block or you say data node to that particular client and all, and it creates a linear list. That linear list is used by client to do the probing for data. Okay, is that clear? Fine then. Right. So this was the first component which we call as HDFS file system. Right. Now comes second important component. That is the programming model. Right. And that is what is MapReduce. Right. So MapReduce utilizes capability of doing parallel processing across different nodes. Okay. So if you see the second component, MapReduce processes data on each node in parallel and calculates the result of the job. So there is also a mechanism to help manage data processing jobs. Right. At MapReduce consists of two phases. And now understand these phases. First one is map phase and second one is reduce phase. Okay. So take up an example here of doing a processing. Now if you see, you start with a file containing all the blog entries about big data in the past 24 hours, and now you want to count how many times Hadoop, big data, and green plum are mentioned. Means you are going to do word count. Okay. So for this, what you will do, you know that file gets split up on HDFS, right, in form of blocks. Then all participating node go through the same map computation for the local data set. They count the number of times these words shows up. When the map step is complete, each node outputs a list of key value pairs. So as of now, I know that you will be confused what I'm talking about. As of now, you just understand one thing: request has been made, and your map phase returns you key value. Okay. For Hadoop, on what node, how many Hadoops are there? On second node, how many times Hadoop has come? On third node, how many times Hadoop has come? Because the data is distributed across different data nodes, right? So you have to ensure that you have grabbed all different blocks of that particular data node, and on those blocks you are trying to find out different words, right? And then reduce phase. So this reduce phase will take input from map phase, which will contain list of all different Hadoop, big data, green plum, along with their count on all different nodes, and it will try to summarize it, right? So assume that you have two data nodes, data node 1, data node 2, on which blocks are distributed, and you got Hadoop word twice in data node 1 and thrice in data node 2. When you go for reduce phase, you will specify Hadoop is 5 times specified in the file. right? So you'll be doing a summarization task, right? If you see here, this is what is map phase. This is what is the file bigdata.exe. What it does on this particular rack you say or data node you say, you got it big data 7 times, green plum, Hadoop 4 times. On second one you got these many number of times. On third one you got these many number of times, right? This is what is done on map phase. Key value, key value, key value, key value, right? In reduce phase, you will come up with the summarized one. Right here you are saying on all three big data was 19 times, on all three green plum was 17 times, on all three Hadoop was 19 times. This is what is the output which is expected. Okay, is this clear? Logic of map and reduce phase. What happens in word count? Any confusion you can ask me. Fine. Now coming to the summary, you say Hadoop architecture, client, job tracker, right? Map reduce. It can be a map reduce task scheduled by job tracker to interact with various nodes and do the task. Okay, this is what is the basic setup that we have. Right now, few interesting facts I will like to share, because if we go too technical, sometimes our brain stops working. Right? If you see, you have various companies now which are contributing to Hadoop. So today, job market is increasing heavily for Hadoop, because almost all companies have adopted Hadoop and they are providing definitely their flavor. Right? For example, IBM is also Hadoop, using Hadoop, Microsoft, Oracle, all of them are using Hadoop. Right? You have some dedicated companies which are working on Hadoop and cloud. Right? So if you see what is the market share, here you will be able to see. This is Cloudera. Then you have Hornet Work. Then you have IBM, MapReduce, Oracle, Microsoft, EMC, Greenplum, Cisco, NetApp, SAP, ThinkBig Analyst. Right? This is also, all these are Hadoop implementations. Right? So I have selected Cloudera, Hornet Work. Okay, as our case study that we'll be doing. In other words, after this training is over, I'm sure that you'll be comfortable with Hornet Work and Cloudera. Right? Then you have Mapper, Data Meter. Horton Work actually is work of people who were there in Yahoo. They came out and they formed this company and they created a product over our network. And this is the product which is being used by Microsoft as base for its own Hadoop implementation. Okay. So jobs are plenty and future is bright once you are up with Hadoop. Right. Now let's encourage ourselves by going through some of the case studies. If you see, these are the industries where actually it is used. You say in automobile, then in retail, right? And if you see in supply chain management, right? In share market and all, gaming industry, everywhere you will find usage of Hadoop. For more details and case studies, you can just go and browse this link. I'm sure that big. See, is Big Insight is also an implementation of Hadoop, Noman. Like you have implementation in Cloudera, that is also one of the implementations. It's a commercial implementation. Fine. Now, if I go here and if I copy this, you will find all companies, and really it's a big list. This provides you a list of the companies where probably you can see yourself. These are the prominent companies where actually they are using Hadoop. So that becomes our workplace as well. Right? And most of them are US based. Is this clear? Now you will be worried that how I will make sure that I can go and I can quickly fix Hadoop in an architecture. These are some of the cases where you can, for example, financial service industry. If you see, Morgan Stanley ran into issues doing portfolio analysis on traditional databases, And now they are using Hadoop to analyze investment on a large scale, and they are satisfied with the results. The automotive industry, Ford's modern hybrid fusion model generates up to 25 gigabytes of data per hour, right? So data can be used to understand driving behavior and reduce accidents, wear and tear, right? And they all are doing this particular analysis or analytics using Hadoop. Then retail uses big data from 10 different websites to feed shoppers. Okay, so this is where actually retail. Entertainment, you have video game industry. It uses big data for tracking during gameplay and after predicting performance, analyzing over 500 gigabytes of structured data and 4 terabyte of operational log each day, right? Brands like ESPN are looking to get into the action. So you have a prominent future when it comes to adoption of Hadoop. Okay, so till here it's clear. Fine. Now, before we go ahead, I feel that we all are clear with what is HDFS, how actually Hadoop architecture works, and all. We'll take a 5 minutes quick break. We'll come back and we will configure our Hadoop. Is that clear? So we'll have a 5 minutes break, and you have to ensure that you have launched your virtual machine. Okay, and you are ready with it, right? Yeah, Narayan, I'm going to show you all that step by step. Okay. So before we go for break, let's start something. And what we have to do, as he asked, we have to go and we have to install SSH first, right? So we'll go to terminal, sudo, that is run as administrator, apt-get install, right? And we will be installing OpenSSH. So I'll write here OpenSSH server. Now I'll just go and press enter. In my case, it will ask me the admin user. Your user password is password. So, and if you see, it is doing. Now 0 upgrade, 0 newly installed. Why? Because I have done the install. Okay, it's already installed on my system. So when I go and write here localhost, I'm able to log in. Okay, so please go ahead and do this. You will get it. This is the command which you have to start. Okay, so just start. We'll be back in 5 minutes and we'll start with the configuration. Okay. Yeah, I'll do that, Manoj. I'll do that. I'll upload the slides there today. On slides, it's there. All steps. Yeah, I'm back. Oh, sorry. If you see, I feel it's working. If not, then you can do su admin user password is whatever is my password I'm typing here, and then if you see, you can go and you can start up with the same thing which I told you, sudo apt-get install open SSH server. It will again ask you password, and you can go ahead. Right? So you can prompt me if you have done the installation of SSH. Luman, Manoj, everyone done. Okay, Narayan has done. All of you have done. Next step. Next step is to go and generate the key. Right? I'll just write the command SSH, or you do what first? SSH localhost you do, and see what is the output. It will ask you for password, right? Rajni, Kranti, Manoj, Krishna, can you just prompt me? It is asking you for password. Enter the password and press again enter. You will find yourself logged in. Now our objective is to convert it to no password login. Right? All of you are there? Okay, fine. So now we have to generate the key. Now see how we are generating the key. I'm writing here the command. You have to replicate it. I just go here and type down on the chat box SSH keygen minus T RSA is the family minus P for password. I am giving empty password, then minus F where it should get stored. I am typing it on the chat box. You will get it in a second. Okay, did you all got it? I'll type down here also in my case. These are single quotes, okay, not double quote, not a single double quote, it is single quotes. Right? Change. If you see, instead of small p, I'm using capital P. Okay. Override, yes. In my case, and if you see this symbol will come RSA 2048, and you'll get the box. Are you getting this? Instead of small p, you have to use capital P. Prompt me if you are getting. Okay, great. Narayan, Manoj, Krishna, Numan, Prem, Srujan. I feel Srujan, you have joined recently, so you need this VMware. We have it on our blog. You can download it from there. Okay, so Rajni is done. Padma, good. So shall I? Okay, Manoj also has done. Almost all of you have done, I believe. Next is to use cat. Numan, you have changed small p to capital P. There is problem in some command that you have written, and this one is not single quote, it is double quote. This is single quotes, two single quotes. You see the command which is written here. You are getting help because your command is not satisfied. Numan, did you got it? I'll be sharing these steps as well with you on the blog. So, okay, Numan, you need to restart your system. Okay, fine. So don't restart it as of now. See the steps. Next step is to do a cat. That is to read the key and make it available in another one. So we'll just go here and I'm writing, same thing you have to write. ID underscore RSA dot pub. Right? Because this is what is the key. It's there in home, admin user, SSH. This is the key which you have to copy. And where you have to copy, you have to copy in a folder called authorized underscore keys. This is what you have to use. Sorry. Have you done? All the steps are specified in your presentation also, which I'll be sharing with you. This is the task that you have to do. Once you have done it, go and do SSH localhost, and you'll find that you get logged in without prompt for a password. Till here you all have done? Padma, yeah, Rajni, Narayan, Kranti. Done, fine. So now your SSH server is ready, and whenever a request will be made to connect to this particular host, it will connect without any password. Okay? Is that fine? Next step. Next step is to go and create your folders. Right? If I go here to my presentation, which is there, which will be available to you, you have to go and create the folders. Right? So be in Hadoop directory itself, pwd, current working directory. Security, just for convenience, right? Yes, right. But you need to have SSH installed because we have seen that when you go for start all.sh, it does an SSH call to your data nodes and the rest of the services to start up. Okay, you can create wherever you want. If you are still getting Narayan password, then problem is there. That means it is not set. Rest of you, I feel Rajni, for you there is no prompt right now when you go and do SSH. Yes. So if you are getting prompt again for password, it means that you have not copied it to the right folder. It means problem is there in your cat command. Padma, till here it's done. Now you have to do an ls. As I suggest you go to your Hadoop folder. You can though create wherever you want, but you see ls, I have done what? I have created a directory called Hadoop data dir, right? That we did by using mkdir and give name of the folder Hadoop underscore data underscore dir. Right? We have already created it. I have created and I have shown you. If I will again try, it will say it's already exist. Right? This is what is first step. And then I'll move to my Hadoop data dir. And in this also I'll create two folders, mkdir name. Now since it is binded by the processes, you can go and you can create directories there. If this is not working, go and do sudo mkdir. So you have to just create the directory, which I am asking you to do. This is binded by the Hadoop process now. But yes, you can go and you can create. First time when you create, you'll be able to log in. I'll just go to Hadoop, and if you see, I have here this file which is locked. Right? Have you created those two directories also Hadoop data underscore data underscore dir? Okay, right. After doing that, what you need to do is you need to go and provide permissions. Okay, and that you will do by using chmod 755, and you can go and you can specify the directory. Right, for all directories and subdirectories. I have to stop the process which is consuming it. Field data and name. So after giving permissions, if you see, next step was to go and specify your configuration files. Okay. For that, as I told you, that entries need to be made to the 3 files which are there here in conf. Now if you see, data and name both are there in this Hadoop dir, right? We can go and we can specify conf. First file that we are going to edit is core site.xml file. This is the first file that we will edit. We have opened this file. You see what configuration you have to do. You have to just go to core site, take a property with this name called fs.default.name, and then value will be HDFS localhost colon 9000. Okay, this is the entry that you have to make, right? So look at it properly so that you will not forget it. I'll just go and I'll make entry. In my case, I'll take here property, opening, property, closing. Please ensure that your XML should be well formed. And here you will take name, closing of the name, value, closing of the value, right? Name of the property is fs, that is file system dot default dot name, right? This is what we have seen. You see, fs dot default dot name, and in this you have to use the protocol called as HDFS localhost and bind it with a particular port. So please do this. Have you all done core site.xml? Padma, Rajni, because after this we have to trace errors if they are there. Okay, all done. Frame, let's follow the standard, our standard within our team. Okay, it should be a free port. So you all have done. I need prompts. Okay, fine. Once you have done this, then you have to open second one, that is HDFS site.xml file. Sorry. Keep open third one also. We'll open it and we'll keep it ready. That is mapred site.xml file. So these two files are there which we have to configure. Now I'll just show you the slide. Please go ahead and configure it. If you see, these are the properties. dfs.name dfs.name.dir dfs.data.dir. No, no, no. Yes, they should be empty. Sir. Uh, what happened, sir? you have to specify the directory. So what we'll do, we'll go here to our prompt. And I'll do pwd. If you see, I'm getting this, right? So I'll copy it. I'll go here. I'll show you. Paste /name. Paste /data. Save it. I'll show you the slide. Okay. This is what will be there in HDFS site.xml. Yeah, DFS. It should be DFS. It should not be FS. It should be DFS. No, you can specify. 3 is the default. I have specified here 3. Okay. Even if you will not specify, default will be 3. Don't take 5 because it is too easy, right? 5 replicas. So number of replications that you want to do, that is what is the number that you have to specify. Is that clear, Numan? Okay. Have you all made entry for HDFS dot XML file? Fine. Now comes the third file, which is map-red site.xml. So this is the place where you will specify the job tracker. And just open the slide, make the entries. I have tried keeping the number of entries. Minimum. If you see here, we'll go to map-red site.xml and we'll make these entries there. Okay. So yeah, I'll send you, Naren. Post station I'll send you. Hello. What happened, sir? specify this minimum entries what we have to make, right? MapRed job tracker, right? Then you'll have MapRed local dir. Okay, the local directory also we need to create under Hadoop data underscore star. Okay, it's a master node. Yes, master node is local host for us. Okay, so I'll just go and make entries. This XML file also. I'm taking here again property, 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 property. 4 I'll take. 4 properties will specify. Uh, in this I'll take name, value. First I'll make the structure. We all are doing together, so it will take some time. Copy, go to second property, paste it. Now once it's done, it will be easy for you to remember. It. We'll go here and we'll specify MapRed job tracker. And here you'll specify the value. If you see, I'm specifying local host and port I'll take as 9001. Same is the case here. Second property, MapRed dot local dot dir, and we'll specify the path to local folder. And for that, I'm going here. I'm making mkdir local, and I'll go here to local and write pwd, and I'll copy this there. Okay. This is what is second entry that we have made. The third entry is MapRed task tracker maximum, and then reduce. The task tracker for map and reduce is what we have to specify, right? Let's go to property and specify here the name MapRed dot task tracker dot map. This is the map task dot tasks dot maximum. So you're setting the limit. Value you can set as 8. Same is there here with one difference, that is instead of map you will use reduce, and value that you will set is 8. Okay, so we have set the properties here, right? So with these minimum number of properties, let's go and save it. We'll assume that whatever we have done is up to date or appropriate until unless we are not getting some errors. we'll get errors, we will go and we will check the error, right? So localhost 9001. This was the third step that we have taken. Okay, have you all done? Fine. Now just go here. I'll go to bin and I'll write here Hadoop. Better is to set the path export Hadoop underscore install equal to whatever is your present working directory, actually pwd. This is what is your directory where your Hadoop is installed. So we need to set it. Export right, check that entry is there. You have your Hadoop installed now, and in order to invoke command from wherever you want, I'll just go. I can set the path also, but anyhow we are there here. We'll go and we will use Hadoop name node format. Okay, set the path. Simple. Export. This is the command that we have used. Is it done, right? You have set. Rajni, have you set the path? Okay, set it then. I'll wait for 1 minute. Okay, so we have done till here, and now we are going to format our node. So /Hadoop name node format, and if you see, it will start doing the formatting. And if in case if any problem is there, it will prompt you the error. And if it is saying, see, you have problem in configuration file. The element type configuration must be terminated by a matching this, right? So it means map-red site.xml, we have made a mistake. So I'll just go here and we'll check it. Property name is closed, value is closed, property name is closed, value is closed, property is closed. So if you see here, I'm not specifying property opening for this. That's what I have to do. So you need to understand whenever error comes that there is problem in configuration file. Don't hesitate in going and reading the error messages. Okay. Now if you see here, what it does, you will get a message saying has been successfully formatted. I'm again showing the command. Please do it. And once done, please prompt me that you have done it. Yeah, please do it. If you are getting error, read the error, correct it. Have you done? You should get this message, has been successfully formatted. Okay. So if you see, once it does formatting, it will do two tasks. Any one of you, have you done? This recording will also be there, so you can go through this recording also in case if you are not able to follow the steps. But I've tried simplifying it, and I'm going step by step along with you to ensure that we all are done. And what message you are getting? You see the error messages you will get. You see, it starts the name node, does the formatting, and it gives you this message saying it is successfully formatted, and then it shuts down the name node.
Hello, Niranjan.
Yeah.
What I'm getting is here reformat file system in home user Hadoop data directory name, and it gave me the option like yes or no, and then
Type capital S, capital Y, capital Y.
Capital Y. I did small y, and it said format aborted, so I have to give capital Y.
Yeah, capital Y.
So it
you
doesn't.
have to give yes. It is asking you yes or no, right?
Yeah.
YES and /NO, right?
Yeah, I think I gave a small y.
No, you have to type down yes, YWES.
Okay, okay. It seems to work. Like if I did small y, it didn't take. Okay, thank you.
Now, yeah, you can do that restart bit later. Now, if you see Narayan, it's shutting down fine because here also you see it is shutting down. But once you should get this message. Okay, fine. Now, once you have done this, what I'll do, I'll take you back to the file system again. I'll take you here, and if you see, I'll go to name, and if you see in name, it has created two folders. One is current, which contains an edit log, image, version, FS time, right? Image, it contains FS image. This is what will be shared or will be used when your name node is down. As of now, no data is there. Right? This is how actually you will be formatting. Just go and see these files should be there. Okay. Now we are going to start the processes that will finalize the configuration. Okay. So how to start now? We are already in bin dot slash start all dot sh. And if you see, I did JPS, and it's telling me that all your processes are now running. And this is the proof that our configuration is done successfully. Narayan, are you getting it? What is the start command? This one we have written, right? Dot slash start all dot sh. With me. XMLs are not yet there, then I feel that your formatting is not done properly. Okay, you all take care of it, and you have to go through the steps again through this video, and I'll be sharing this presentation also with you, so that steps are clear with you, right? But if you see, as of now, we have started, and here it is showing that all processes are running. You see, these are the Java processes which have started, and this confirms that your installation or your configuration has been done successfully. You have now your Hadoop up with one name node, one data node, then job tracker. You have secondary name node which does housekeeping task, and you have a task tracker whom job tracker will delegate or provide the task. Okay, fine. Now comes our last test. That is, once we are getting all the processes, we can go and we can check whether your app server, your web server has started up properly or not, or it's able to show you the tracker or not. So I'll go here and I'll simply specify HTTP, right, localhost followed by 50070, this is default, and if you see, it shows me name node localhost 9000, live node 1, number of unreplicated block 1. We have not written anything, so there is no question of DFS getting used, 0. DFS remaining is this, non-DFS used is this gig, and configured capacity is 26.6 TB. Okay, so this shows that your name node is configured properly. Okay, this is how you will confirm the setup or installation. Now you can go to name node logs, and you can see all log entries which are made. This is the recent log which was made. So I'll just go and click on it, and you'll find that it has logged everything. Okay, this is how you will be confirming the installation. Browse the file system. You have temp here. You have Hadoop admin user in that MapRed system, right? Then go to parent directory. So you have everything up now. Is this clear? You see permission denied for user this, access this. Right, so don't worry, all this we will see. But once you are getting this page, it means your Hadoop is up. You all are getting? I feel that whoever has followed the right steps along with me, you might be getting. You all are getting? Core site.xml, right? I'll show you. Yes, so Manoj, yours is also up. I'll copy all these files for you so that you can use it. Numan, have you seen? Similarly, HDFS site.xml and MapRed site.xml. This is how you will be working. Yes, yes, it's in the web app. Apart from that, we can use command prompt also. Tomorrow, I'll be talking about interfaces to HDFS, where we will discuss FS shell. We will discuss how to use Java in order to get the details through your own programs. Where you get the different port. These are default port numbers, okay, at which it starts. So how to configure that port also I will tell you. But as of now, you should get this so that we can start working with HDFS file system, and your labs will start after that, right? So next session we will talk more about HDFS and HDFS commands that we use, different type of interfaces which are there, and whatever commands we will use here, it works with almost all distributions, right? Whether it is Cloudera or whether it is MapR or it is RNetworks, it works with all.